Okay, students, Bensky here, Astronomy 101, Winter 2021. Welcome to week 7. So we're starting this week. Wow, the quarter's just going right by. So we have this week and 3 more left, it looks like. So just a couple things to summarize where we're at. The average on the exam last week was a very respectable 86%, up 2 percentage points from exam number 1. I hope the shorter exam sort of jived with you a little better than the longer one did. So the grades just looked okay to me. So I hope it worked out well for you. We'll keep the third one at about that length as well. Looks like it kind of works better for most of you there. And then last week, I hope you got the idea of the sun and all that awful stuff that it's spitting out, the solar wind that just fills the entire solar system. No, there's not a single planet that isn't subjected to these protons and electrons coming out of the sun, the solar wind. And I hope you understand how it's the Earth's magnetic field that really protects us. And if you ever heard of the northern or southern lights, which are those auroras, that's all evidence of the solar wind and the magnetic field of the Earth doing its job and all that sort of thing. And so, but I hope you got the idea that if you're a planet like this and the solar wind is coming along, if you have a magnetic field, the solar wind would just sort of deflect around you and make it safe, at least for biological organisms to exist. Like the surface on Mars, for example, without that magnetic field is very sterile. It'd be very hard for anything to live on the surface of Mars. That's why it also makes it tough to look for life there, because you're going to have to dig or look somewhere that's not just right on the surface. And help also the idea of active geology makes a little sense to you. Particularly, I always like those subduction zones where you have 2 plates coming at each other and one just gets pushed under another one. And this is the hot lava magma of the Earth below here. And so there's like a crater right here on this plate, and it gets subducted under another one like that. And this crater is going to be gone. It's going to be melted away, and so that geological history is going to be gone. But that's the nature of an active geology, and it definitely ties into how the planet behaves, liquid core, all that sort of thing there, because if it certainly has active geology, it's going to have that hot core that's driving the process, and it gives you an idea that if it's spinning, it probably has a magnetic field and all the things that we discussed. So I love that comparative geology of planets. I think it's so interesting and just a nice 4 or 5 good facts you can base things on to learn about planets. And I hope you got a little bit of taste of what light is, okay? It's a wave, but it can also be these little particles of light, like baseballs of energy floating around that we call photons, or a wave or a photon, depending on how you're looking at it. And also the activity on the gnomon, just sticking a stick or a pencil straight up, looking at a shadow is very historical. Those gnomons go back something like, thousands of years, and whenever you sort of travel anywhere and see a stone structure that's just sticking straight up in your museum or something, it's likely a gnomon like that, because humankind has been fascinated with tracking the sun and understand patterns of the sun for probably as long as humans have been in existence. And also when I read that gnomon activity on that bit about writing how you would get off the deserted island, I always get a laugh about how many of you just want to stay on the island. Like, why would you want to get off, a tropical island? But I don't know, it's just kind of funny. I don't blame you either, but eating coconuts all the time, I don't think it's good for your digestive system. But anyway, I just kind of get a kick out of reading some of those creative writing in there a little bit. Okay, so this week, what we're going to do this week, we're going to move on a little bit more about how light behaves. So beyond what it is, we know it's a wave or it's a little photon wisping around, that's what it is. But now, how does it behave? And by behave, I mean when it finally encounters something like a planet or an atmosphere or a water droplet in the sky. And so what this leads is 2 key behaviors. One is the law of reflection. Now, you may not be able to see this, but it's a little bit of a hand mirror I have sort of in the garage for inspecting things, but you know how mirrors work. If a light ray comes in like that, it'll hit the mirror and just bounce right off. That's called the law of reflection. But you don't always just need a mirror for reflection. It turns out reflection can happen off of just about any object you can see. It means light went in and reflected off it, like even the microphone I'm talking to you. I can see the microphone because light's coming in, hits the microphone, and bounces into my eye, and that's a law of reflection also. And so, but there's also this other law called the law of refraction, which is what happens when water sort of goes through something that's transparent, sort of like this glass of water here. Because I can certainly see the camera a little bit through the water. Light travels through the water. And it leads to all these funny things here, like if I put my mirror in the water, I don't know if you can see this on the camera, but you can see how sort of the stick or the straight part of this mirror is all busted up looking in the water. And you can do this at home. You can get a glass of water and put a pencil in there and see that the pencil has this like little break point in there. And that's all because of the law of refraction, because light has to travel into the water, and it turns out it bends in funny ways when it does that. So we'll cover that this week. And one of the great outcomes of the week is one of my favorite parts of the class, because it allows us to describe color in nature that we see, which is just a wonderful thing. So what am I talking about? Well, as always, look up during the day. The blue sky, the red sunsets, the white clouds, a nice rainbow. Who doesn't like seeing a rainbow once in a while? Something called the green flash, these colors in nature. You know how beautiful nature can be in the sky and things, and that's what we'll talk about this week. If you can get a handle on the law of reflection and refraction, it'll lead to something called dispersion and things like that, and it'll tell you where all these wonderful colors in nature comes from when you just look up at the sky. We have a little dinosaur bit for you on the law of reflection, how some dinosaur in Jurassic Park sort of did something. And then, of course, there's also the famous song, sing it with me. Come on, sing it with me. Twinkle, twinkle, little star. Yeah, I'm not going to sing any more than that, but you all know that song. There's some truth to it, and we'll see about that with the law of refraction, as we'll see. Light behaves. Stars actually do twinkle. Okay, so we get a lot of those 48 questions answered this week. A lot of answers are going to come out, so be ready for that. And lastly, I'll sign off now, but as always, Canvas has been updated. I hope you'll find new video check-ins on the app. There's a new quiz, a bit more reading this week. I think we're getting into the planet Mercury this week. And there's a new activity that we're finally going to get out, the solar panel and the voltmeter that you sort of warmed up with, and we're going to make our first measurement with it. Okay, this can be one of two measurements we're going to make using that equipment this quarter. Okay, so that's it for you for a little recap of week 6. Some things to look forward to in week 7. I continue to communicate with a lot of you on Slack, which is great. Hit me anytime. Happy to chat with you. It's led to several Zooms as well, and it's nice to see you, some of you on video once in a while. Nice to meet a few of you. And that's it. Okay, everyone. So this is Bensky, Astronomy 101, signing off week 7. Everyone, I hope you have a nice week, and I'll see you next week on one of these live updates. Okay, bye, everyone.